school until almost 4, so I feel like I'm not rushing home to anything. Yeah, they get out at 3:35, and by the time they get home, it's like 4. Yeah, it's crazy, the late tier. All right, here we go, really quick. Guys, I saw some amazing answers. Basically, in this problem, you are taking a solution that is 55% acid, and you are mixing it with another solution that is 28% acid to make one solution that is 750 milliliters big, and 44% of it is acid. So you've been asked to find how many milliliters of each solution you should mix. So a lot of you use X and Y, that's beautiful. I said let F equal the milliliters of 55% solution that you need to put into this mixture. And I said let T equal the milliliters of 28% acid that you need to put into this mixture. All right? So think about it. If you're going to take so many milliliters from this solution and mix it with so many milliliters from this solution, they have to add up to how many milliliters is this solution going to be? What number? 750. So F plus T has to add up to those 750 milliliters, right? Now, let's bring the percent in. If you're going to use this many milliliters of the 55% acid solution, well, guys, 55% of those F milliliters are already the acid. So what's 55% of F? Point that. Perfect. Plus, if you're going to use T milliliters of the 28% acid, well, that means 28% of those T milliliters is already acid. So what's 28% of T? 0.28 T equals blank space. They never give you that last number that you need in this problem. In the end, I want this mixture to be how much acid? 44%, and it's 750 milliliters big. So that means 44% of those 750 milliliters is acid. So how much acid is that? What's 0.44 times 750? Now, I got 330, but if you had the 43, then 0.43 times 750, I think you got 322.50, which is fine. All right, and I saw a lot of great answers. All right, so that's going to wrap up our system word problem section. We're going to move into the next section, which is still going to deal with systems. However, I feel like I got to warn you guys. It's a lot of work. The next section is you have to solve a 3-equation, 3-variable system. They're not going to make you write it, but they're going to make you solve it. So guys, basically, the only way I teach you to solve it is the elimination method. It's going to feel like, I think I said this yesterday, it's going to feel like the elimination method on steroids. It is extremely jacked up. But at the end of the day, it is the elimination method. You just got to do it a lot, all right? So these are going to feel like a lot of work, but it's not the hardest thing we've done. It's probably just the longest thing we've done, okay? All right, so you guys have your notes in front of you. I want everybody to look at that little tiny list of steps that I gave you. All right? So I gave you guys basically a cheat sheet that you guys can have on you when you're working on your homework and whatnot, and this literally tells you exactly how to solve these problems, word for word, all right? So keep this handy as you're getting used to this process. I just need you guys to fill this in. When you solve a 3-variable, 3-equation system, this process is going to take you 5 total equations. Guys, they're going to give you 3 equations, but you are not going to be able to get to an answer until you have 5 equations, which means you're going to have to make 2 of them on your own, all right? And then, yes, you need 5 total equations. You are going to need 3 total rounds of elimination before you get to your first answer. So you should have eliminated 3 total times just to get to the first answer. So I'm just going to repeat myself. Yes, this is a long process, but I'm telling you right now, it's not the hardest thing I'm going to ask you to do this year. But the one thing that's going to keep every single one of you on track is organization. You have to be organized in this process, and you have to take your time. Every year, the students who are trying to rush through this because it's long and they want to get it over with, they're the ones who make the mistakes, and it ends up taking them more time because now they have to try and find their mistake or they have to start all over. So for the love of God, please take my advice. Let's be organized and let's take our time. And then we should only have to go through the problem once to get to those right answers. Ready, Brendan? Brendan, you got this. All right, here we go. So, what's up? We're done with word problems for right now. Yep, probably for this chapter, okay? All right, so have these steps next to you. I don't want to read them now. They won't make any sense. Let's use them to do the first problem. Yeah. Oh, I'm sorry. Where did I put them? Oh, you're there. Sorry, did I skip anybody else with the page of notes? These are them. We don't have those as steps. That's what I skipped.
Yeah, you did skip this one.
I think I forgot to give you one, but they have that. I don't know what I did. She's got it. You know. What did I do? I blame Steven. Everybody else has notes and steps.
Yeah.
All right, here we go. Here we go. You are probably going to want a calculator. Can everybody grab one? All right. It's never a good sign when your math teacher gives you a problem and leaves the whole page blank. It's going to take the whole page to get to this answer, all right? I know, really talking these up, aren't I? Let's go. All right. Our job is to solve this system for X, Y, and Z. So now there are 3 equations with 3 unknown variables in them. And again, the X in the first equation represents the same X in the second and the third. It's the same missing numbers, all right? All right, number 1, step 1. This is an organization step, and I think it's worth doing. I think the first thing you should do when you start these problems is number them equation 1, equation 2, and equation 3. And that just keeps you organized. And I think organization is our best friend here. So we're going to call this 1, this 2, and this 3. I told you we're going to need 5 total equations before we even get our first answer. So there's 3 of them. We need a 4th and a 5th. All right. This is a little hard to teach because there's a lot of different things that we could do to start it, and every single one of you could be right. You could do this, they could do that, and everybody's right. But once you make the first initial decision and step, it does map out the rest of the problem for you. All right, so if you look at the problem, step 1, we number. Step 2. Step 2 says, pick any 2 equations that you want and eliminate any variable you want. So guys, pick equations 1 and 2, eliminate X. Pick equations 2 and 3, eliminate Z. Pick equations 1 and 3 and eliminate Y. Do whatever you want. I did put in parentheses though, just take a peek if maybe there's like an easier 2 equations to get started and eliminate a variable. If you guys look at these right now, is there like 2 equations and a variable that would be really nice to eliminate? The first 2 and Y. If I took the first 2 equations the way they are written right now, Y already eliminates on its own. So I think that would be the best possible step for you to get used to this problem. So let's do that. Let's pick equations 1, and this is what I do to keep organized. We're taking 1 and 2, and let's get rid of Y. And we've chosen that. Now, the minute you choose that, this will predict what you have to do in step 3. All right, so guys, some of you are going to do it in your head right now. I'm going to rewrite them just so you have it written together. I'm taking equation 1, which is X plus Y plus Z, and that equals 6. And then I'm taking 3X. Now again, see all this rewriting that we're doing? It's a disaster. It's a recipe for disaster of you writing something down wrong. So take your time and make sure you're copying everything down right. Oh, look at those Y's. That is why we're doing this. Plus Z, and it equals 8. All right, let's add them together, and let's eliminate Y. This is the elimination method. When I do this, what's X plus 3X? Boom. What happens to our Y's? That's why we did this, right? That was as planned. What's 1Z plus another Z? 2 Z's. And then that equals what's 6 plus 8? 14. We are going to call this equation 4. So now we have 4 equations. I told you we're going to need 5. All right, so now the weird thing is you've made this equation 4, but guys, you're not ready to use them yet. So kind of put them on the back burner, let them simmer a little bit, hold up. Now we go to we are on step 3. Go back to the beginning. Pick 2 different equations now, but you have to eliminate the same variable again. What we are trying to do is to create a 5th equation that has the same 2 variables in it. I want to make it so that y doesn't exist. The minute you choose to eliminate y in the first step, you are going to have to eliminate him again in the next step. Every year I get a student who's like, I think I'll eliminate x this time. Go ahead. You are wasting your time. It will do absolutely nothing for you in the next step. So the minute you choose to eliminate y, you have to eliminate it again. All right, so now guys.
So what if you do like for the first first equation, what if you do x because it works out, and then like
Then who do you have to eliminate in the next one?
x?
X again. You have to do the same variable again. All right, so guys, let's look. We already took 1 and 2. So that means we could take 1 and 3 and look at their y's because we know it's y. So I got this y and I got this y. I could make that happen. Or I could take 2 and 3 and get rid of their y's. I kind of like 2 and 3 because they're already the opposite sign, right? So I'm not going to have to mess with making something negative or positive. So I'm going to choose that. I know I have to eliminate y. I know it has to be 2 different equations. So let's do 2 and 3. But again, somebody else might have done 1 and 3, and they're not wrong. All right, if we're going to pick equations 2 and 3, and we're going to get rid of y, well, look at them. What number do I need here so that it cancels with this one? A -3, right? So it's already negative, so what am I going to times this by to make it -3? A 3. So over here, put a 3. Write down what number you're about to multiply everything that by. I don't want to mark these equations up because you're going to have to go back to them at some point. But I definitely want you to write it down so you know who you're timesing by. And now very carefully, everybody times this whole equation by +3. 3 times 3x is 9x. And this is what I'm telling you. The slower the better. Don't make any silly mistakes. 3 times -y is -3y. That's what we were aiming for. 3 times +z is 3z. And then that equals 3 times 8 is?
24.
Beautiful. All right, now bring down equation 3. We don't even have to change it. Now again, are there going to be systems out there where that maybe you have to change both equations to eliminate y? Yeah, well luckily this ain't one of them. All right. 2x plus 3y. Oh, look at those y's. They are good to go. Minus 2z equals 10. All right, let's add them up very, very carefully so we don't make any silly mistakes. What's 9x plus 2x? 11x. What happens to those y's? As planned. What's 3z's plus -2z's? 1z. And then that will equal, what's 24 plus 10? 34. We will call this equation 5. This always makes me think of Nemo. We will call you equation 5, and you will be my squishy, and you will be mine. All right, now, it's kind of like, hard. What the hell did we just do? Bring equation 5 over here with equation 4 so you can see them together. 11x plus z equals 34. That was number 5. So guys, we eliminated one time, we got equation 4. We eliminated a second time, we got equation 5. Now, look at equation 4 and 5. They are a 2-equation, 2-variable system that we're going to be able to eliminate a third time and get our first answer. So now, take 4 and 5. Now we are on step 4. Take equations 4 and 5 and eliminate one of their variables. Either eliminate x and get an answer for z, or eliminate z and get an answer for x. Does anybody care which one I eliminate? I would eliminate z. That looks a lot easier to kind of eliminate than the thing. I mean, that's doable, but I like that better. So we're going to take 4 and 5 now, and we're going to eliminate z, and we're going to get our first answer. All right, so we're taking 4 and 5, and we are eliminating z. Notice you can't be like, Hardy, should I be eliminating y? No, because y doesn't exist in this system anymore. So we only have x and z now. All right, if I'm going to eliminate z, guys, what do I need him to be to eliminate with that one? A -2z. So let's times this by a -2. Again, I'm going to write it down, but I don't want to go marking everything up. All right, so -2, very slowly, times equation 5. -2 times 11 negative 22x. Negative 2 times positive z, negative 2z. And that equals negative 2 times positive 34, negative 68. All right, let's bring over 4. I don't even have to change that. Look at those z's. That is nice. Okay, let's add them up. And we're about to get our first answer. Negative 22x's plus 4x's gets you how many x's? Negative 22x plus 4x gets you how many x's? Negative 18, don't lose your sign. They cancel, that's what we planned. Equals, what's negative 64 plus 14? Oh, sorry, I said the answer. Almost the answer. Negative 68 plus 14. Negative 54. And then there it is. How are we going to solve this for x? Divide by negative 18. Don't you make some silly mistake now. Don't you mess up signs now that you're finally here. What is negative 54 divided by negative 18? Woo! All right. We did it. You will 100% work the hardest for that first answer. The other ones come much faster just by pure substitution. All right, so guys, everybody gets the first answer and they're like, oh my God, okay. And they want to take it and they want to go back to the original problem, right? Because that's normally what we do. But if you know x is 3 and you put them there, or there, you still don't know y or z. Are you able to solve anything? No. So you definitely can't jump back to equation 1, 2, or 3. But you could jump back to what other equations? 4 or 5. So now we're on step 5. Take your first answer and plug it into equation 4 or plug it into equation 5. It's a personal choice. I know x is 3. Do I want to plug them in there and solve for that z? Or do I want to plug them in here and solve for that z? I kind of like 5. So I'm going to plug them into 5. So now we're going to take this answer and we're going to plug x equals 3 into 5. All right, so if we do that, if we plug them into 5, that's going to be 11 times 3 is x, and then plus z equals 34, right there. All right, guys, what's 11 times 3? Start cleaning it up. 33 plus z equals 34. What's the only thing you have to do to get z by itself? Minus that 33 out of there. What is 34 minus 33? Z is 1. Oh, we got 2 answers. We already got 2. Now we're missing the third answer. The third answer, the answer you get last, will always be the one that you eliminated in the beginning because he doesn't exist in equation 4 or 5. All right? So now that you know x is 3 and z is 1, where's the only equations right now that have a y in it? Now you got to go back to 1, 2, or 3. So now you're going to plug x and z into 1, 2, or 3, and you will get your last answer. Anybody have a preference? You ain't going to 1. You got problems, right? So now we're going to plug this and this into 1. All right, if I do that, that is 3. Plus y, I don't know him yet. Plus z is 1, and then it equals 6. Guys, clean this up. What's 3 plus 1? 4. Plus y equals 6. What's the only thing I do to solve for y? Get that 4 out of there. Good job, Jake. Minus 4, and y ends up being 2. And you're done. And now you have solved it for the 3 numbers that will make all 3 of these equations true. So again, I hope no one's sitting here saying, yeah, this is the hardest thing she ever made me do. Because it's not the hardest. Is it the longest? Absolutely. Is it the one that's going to have the most room for error? Absolutely. But the math is just elimination. It's multiplying and adding. All right? All right. So now your homework is on Delta Math. I am like 99% sure that Delta Math is going to make you type your answer like this. I think they're going to have answer boxes that you're just going to type each one into individually. So then you would be x is 3, y is 2, and z is 1. If they don't ask you to write it like that, our book made you write your answer. It does? Okay. Our book, just so you guys know this, you know how when you solve a two-variable, two-equation system, you wrote your answer as an ordered pair, x comma y? They would make you write your answer as an ordered triple, x comma y comma z. In alphabetical order, they would just make you write them 3, 2, 1. X, Y, Z as an ordered triple, not an ordered pair. All right? All right, let's try and do one more before this bell cuts us off. The more practice you get, you will find that you do get into a rhythm. Yeah. Say it. Why? Can we call her when class is over? I don't know what you expect me to do. We're in the middle of math class. What's up? So normally, what you can't text mom?
I did.
I don't know what you want me to do with this. I mean, all right, here we go. Here's what should you do first to get yourself organized and ready? I would want nobody going to bed. I really want everybody here. You got to see at least 2. You got to see at least 2. I get you for 40 minutes. 1, 2, and 3. All right. Now, tons of ways to get started. Let's try and pick the same thing so that we can all stay on the same course. Technically, though, how do you get started? Pick, that's you. Any 2 you want and eliminate any variable. So start looking. Who do you like? And we'll make a team decision. 83. Yeah. I guess. Kristen, they need you in the office. All right, here we go. Let's see. I always look right now. Does anything disappear? Nope. So now I'm looking at opposite signs. That'd be easy. That'd be easy. This would be easy. This would be easy. That would be easy. This would be easy. I start looking for things where I don't gotta mess with signs. But guys, there's gonna be systems out there where you're like, man, I gotta change both equations just to get one variable to go away. Yeah, we're trying to avoid that. So does anybody have a strong opinion? Let's not do y though, because we just did y in the last problem. The first 2, who are you getting rid of? X. I like it. So we're doing 1 and 2. Let's get rid of X. Guys, the minute you make that decision though, who do you know you're gonna end up eliminating again? X, because you got to eliminate the same variable again in the next step. All right, here we go. If I'm going to take these and eliminate X, who do you need this to be to cancel with that? A -3. So times everything by a 3. Let's not mark it up, but let's put it off to the side. All right, I'll meet you at the end. 3 times -X, 3 times 3y, 3 times +z, and then 3 times -10. Okay? Everybody bring down equation 2. You don't even have to change him. And let's add them together. Bring it down nice and slow, though, so you don't make any silly mistakes. Okay? Add them together, and let's see what equation 4 comes out to be. X's are gone. Right? Double check with me. I got 11 Y's now. I got a +1Z. And I got a -27. And we will call that equation 4. All right, we don't use them right away, though, so put them on the back burner. Now, what do you do next? What's that?
I don't know.
What do you mean find out? Pick 2 different equations, but who are you eliminating? X. All right, so we already picked 1 and 2. So look at the X's only. That means you can pick 1 and 3. Nice. Or 2 and 3. Whoa. If you want to eliminate X from 2 and 3, you got to change both of those numbers. But if I want to eliminate X from 1 and 3, I only have to change one of them. So I think your best bet is 1 and 3. Get rid of that X. All right, so if that's true, What do I need this x to be to cancel with that x? A -2. So we're going to make that times it by 2. So again, don't mark it up, but off to the side so you know who you're multiplying by. All right, very slowly, everybody do this. Let's see if we get the same answer. Nice and slow. 2 times -x, 2 times positive 3y, 2 times positive z, and then don't forget 2 times -10. All right, let's bring down that equation 3. I don't even have to change him. 2x minus y minus 4z equals -7. Let's do it. Add them together and let's get our equation 5. As planned, see you later, x's. 6y plus -1y. 2z's plus -4z's. And then -20 plus -7. We will call you equation 5. Let's bring him over so we can see him with 4. All right. And now, forget everything else. Pretend that equation 4 and equation 5 was the system you were given. It's 2 equations with the same 2 variables in them. What am I going to do one last time to get my first answer? Eliminate. Either eliminate y or eliminate z. Anybody have a preference? I think you should do z as well. All right, so now we're taking 4 and 5. Let's get rid of z. Okay, if I do that, what do I need this z to be to cancel with -2z's? 2z's. So let's times everything by 2, right? All right. 2 times 11. 2 times positive z. All right, nice and slow. Take your time. 2 times -27. -54. And now let's bring over 5. We shouldn't even have to change him. Those z's look good. All right, add them up. And we should get our first answer here. 27 y's. Z's eliminate as planned equals -81. What is the only thing you have to do right now to get your first answer? By who? 27. Don't mess up signs now or there. What's -81 divided by +27? -3. There it is. First answer, right? You worked so hard for that one. Now, let's baby step it. Where are you going to take -3 and plug him in to get your second answer? 4 or 5. You can't go back to the beginning yet. You don't know enough answers. So let's go back to, do you want to go back to 4 and solve for this z? Or go back to 4 and solve for that z? I like 4 too. I'm going back to 4. All right, we got 11 times -3 plus z equals -27. I'm getting a little crammed. I hope we're okay. What's 11 times -3? -33 plus z equals -27. What is the only thing you have to do to find z? Add that 33 over. And -27 plus 33, z is?
14.
No! 6! Beautiful! Z is 6. So now you have 2 answers. You know why? You know z. The one you eliminated is always the one you find last. Where are you going to go to find x now? Back to the original. Pick your fave. Plug them into 1, plug them into 2, or plug them into 3. I like 1, so I'm going to go back to 1. All right, let's do it. So we're going to have -x plus 3 times, who do we say y is? Negative 3 plus z, what's z? 6, and it equals negative 10. Clean that up. Negative x, what's positive 3 times negative 3? Negative 9 plus 6 comes down, equals negative 10. Negative x, guys, what's negative 9 plus 6? Negative 3 equals negative 10. What are you going to do first to start getting x alone? Add 3. And now we get negative x equals negative 7. Divide by negative 1, and who's x? 7. And x is 7. And now you have all 3 answers. So again, you're going to have your answer boxes to fill in. So we got x is 7, y is negative 3, and z is 6. And then, like, just so you're used to seeing it, our book did make you write it as an ordered triple. X, comma, y, comma, z. How do we feel? Are you guys okay? Like I said, you have that list of steps. It literally guides you through. You are going to be your own worst enemy, because I'm telling you right now, the reason students get these wrong is not because they didn't know the steps. They just made silly mistakes. So for homework tonight, it's on Delta Math. I have assigned you 3 problems. You have to do 3 of these by tomorrow night at 11:45. Okay? All right. Oh, also, really quick, I'm probably going to give you this again tomorrow to practice. Monday will be a review of this and word problems, and Tuesday will be a quiz on this. I can only ask you probably 2 of these on a quiz, and then the rest would be on the word problems. Yes.
If I turn in the homework like tonight, but a little later than 11:45.
Anything after 11:45 is late. I assigned it to you yesterday.
I know, I forgot.
That's fine. Just get it done before I leave. Thank you for waiting, Bianca.
Can I borrow your
One of those? Absolutely. Just make sure you bring it back tomorrow. I know, Jake. It's easy to forget.
I was like, I don't have a calculator. I'm gonna put it on myself and get first.
No, please borrow one. As long as it comes back, I don't mind.